let's have a look at this Leaving Cert question. Question 12, Part C, from the Leaving Cert of 2017. It's one of these half questions. Full questions are 56 marks. Half questions are 28 marks. Should take you 10 minutes max to do this question. They're very popular questions because they're half questions. They can't ask you anything particularly difficult in terms of a nasty calculation. So have a look at this in your physics book, in your notes. So it's recently been suggested that 17th century Dutch artist Rembrandt used a concave mirror to help him etch self-portraits by projecting an inverted image of himself onto a copper sheet. So they're asking you to draw a ray diagram, illustrate how Rembrandt used a concave mirror in this way. So for 10 marks, we'll do that. Look, we know our ray diagrams really well. So let's have a look at this in detail. So here's my concave mirror with its real focus and the center of curvature. Now, I want to produce a real image. There's only real images can be formed on screens. But that's what I want to do. I'm going to put the object somewhere outside the focus. I'll also put it outside C, though it doesn't matter if you put it between C and F. So I want to draw that ray diagram. So I need two rays of light to draw my ray diagram. The first ray of light is, as usual, take a ray of light from the tip of the arrow, parallel to the principal axis. What happens to that ray of light? That ray of light will be reflected down through the focus. Take my second ray of light. My second ray of light is a ray of light from the tip of the arrow through the focus. What happens to it? It gets reflected out parallel to the principal axis. It's actually the reverse of the first ray. So from the tip of the arrow through the focus. That ray of light gets reflected out parallel to the principal axis. Where do the two rays of light meet? You can see where they meet. They meet between C and F. The tip of the arrow actually finishes down here. We're talking about an inverted image. And if I did all the other points, then they would finish like this, going back to the principal axis. There's my image I. Do I need to do anything else? No, just draw the ray diagram. No explanation needed, no nature, anything like that. There's 10 marks for that. So once they see you're using two rays, they correctly meet and so on, you will get your 10 marks. Then we want to go on to the problem part of it. So let's go back to our exam question. So looking at my exam question, Rembrandt used a concave mirror of focal length 60 centimeters so that the image on the copper sheet was only half the size of the object. You've got to calculate the distance from the sheet to the mirror. The sheet is where the image is formed. So they're asking you to find V in part 1. And then the distance of the object to the mirror, they're asking you to find U. So it's a problem where they give you F and they give you the magnification and they want you to find V and then U. So let me have a look at that problem. Well, we're talking about the focal length is 60 centimeters. And of course, that's a real focus. That'll be plus 60 centimeters. So concave mirrors have real focuses. And the other thing I'm told is the magnification is a half. Now, when we did problems before, that might have been plus a half or minus a half. But here, I'm sure it's plus a half. How do I know that? Because the image is being formed on a screen. And only real images can be formed on the screen. So that has to be plus a half. Write down your mirror formula. They'll give you 3 marks for that. There's 9 marks altogether to actually find the value of V. So 1 over U plus 1 over V equals 1 over F. I'm also going to write down the magnification formula. The magnification formula M is equal to V over U. Replace M by V over U, and that's equal to a half. Then cross multiply. Slide the 2 up to the V, 2V, and the U up to the 1 is equal to U. Or multiply both sides by 2U, whatever way you want to do it. So, I have a relationship between V and U. I don't know V and I don't know U, but I have a relationship between them. U is twice V. Now I'll go over to this formula here, and I can replace U by its value of 2V. So that's 1 over 2V plus 1 over V is equal to 1 over F, 1 over 60. So now I've got an equation just with one unknown in it. I'm just missing the V. So I'm going to multiply right across by some number that will get rid of all those fractions. I'm going to multiply right across by 60V. So 60V, multiply each term by 60V. So 2V into 60V, 30, plus V into 60V, 60, is equal to V. So V is plus 90 because it's a real image. It'll be 90 centimeters. So that's part 1. You got 9 marks for that. You get 3 marks for writing down that formula. You get 3 marks for this stuff around here with the magnification, and 3 then for writing down the correct answer. So V is equal to 90 centimeters. Part 2. Well, that's easy now, isn't it? Let me write down part 1 there. That's easy because you've got U is equal to 2V. So if you want to find the value of U is equal to 2 times V, which is equal to 2 times, you just worked out 90 for V in part 1. So you get 180 centimeters. So there'll be 3 marks for actually doing that. And then the last part is kind of one of those real-life applications or SDS parts. So they're saying a concave mirror can be used to produce an upright image. Why was that image of no use to Rembrandt? Well, if I'm going to get an upright image, remember that's a virtual image where the object is inside the focus. So why is that? Well, it's a virtual image that will be formed. All virtual images are upright. All inverted images are real. So it's a virtual image, and you can't form virtual images on a screen. So it cannot be formed on a screen. So it'll be 3 marks. It'll be 6 marks altogether, 3 and 3 for each of these. Cannot be formed on a screen, which is what Rembrandt was trying to do by putting the image onto a screen and drawing from that image. So that cannot be formed on a screen. So look, that should all take you about 10 minutes. I might have taken a bit longer, but that doesn't matter because I'm explaining a lot of things. But again, it's an easy question. Ray diagram, a nice calculation, and a little bit of real-life physics thrown in.